skipping ahead, we're on page 430.
Example 2.
Yeah, it is right. Okay, so a box is to be built from a rectangular piece of cardboard. And that is 25 centimeters wide, 40 centimeters long. And we're going to cut out little squares from the corners so that we can fold it up and make it an open box. But they do this to figure out how much cardboard they need to order to make these boxes. And they want to order just the right amount so that they don't make to have too much extra.
Don't they have
Yes.
Don't they have a computer to do it?
Yeah.
They have a person that has to program the computer to do it. I mean, a computer doesn't come up with all this stuff on their own.
Some point in time it will. I mean, yeah, once the program is set.
So, find the size of the corner square, which will produce a container that will hold the most amount, and I guess it's soup, all right? Most amount of soup. Oh, maybe those like broth. Those broth.
I made ramen yesterday. Oh, you make a bowl.
No, there's you can buy broth in a box.
Yeah. Oh, yeah.
That's what I'm talking about.
Really?
Yeah.
Huh?
You can buy anything.
It has a lid on it, though.
Yeah, I've seen that.
This one's not going to have a lid. So step 1, if you didn't do it yesterday, step 1 was to determine the quantity that is to be maximized. So the size of the corner square, which produce a container that will hold the most amount of soup. So what are we talking about? Holding the most amount of soup. What is that?
Volume.
Volume.
What are you talking about? Too late.
So we're looking for the volume of this box. Step 2 is to draw a picture.
I know, she's drawn 2 lines. We're slowly getting there.
Okay, so this is supposed to be, it says 25 centimeters wide and 40 centimeters long.
The picture is not proportional. It shouldn't be.
Mine is.
Yours is 25 inches long.
Then it says we are going to cut out squares from each corner. So they're squares, so that means they're X by X.
Don't make this geometry, please. Too late. I was like, I don't know what you have.
Okay, that's step 2. Step 3, write a primary equation that represents the quantity that is to be optimized. So, we're trying to optimize what?
The corners. X.
The volume.
The volume.
Woo!
So, volume of this box, when you fold it up,
Yeah.
volume is length times width times height. So when I take out these X's,
It'll be X height.
yes,
Cool.
the height's going to be X, good job.
I made 40
What's it going to be from here to here?
40 minus 2.
Okay, so that's length, and what's the width?
25 minus 2.
Yep. And the height? X. Now, we only have one variable here.
Good.
So that's very good. The problem we did yesterday had 2 variables. Step 4 is if it contains more than one variable, you have to come up with another equation so you can make it just one variable. So we don't have that, so we don't have to worry about it. And then step 5, differentiate the primary equation to find the maximum or minimum. So we're going to need to multiply this out so we can take the derivative.
No.
Yes. So I'm going to, I guess, just FOIL these 2 first. So 40 times 25 is 1,000.
Yes.
Then minus 80x minus 50x plus 4x squared
Times X.
times x. So simplifying and distributing the x. I have 1000x minus 130x squared plus 4x cubed.
Oh, it's 130.
Nobody crying yet?
I can.
You
yeah.
can on cue though, that's not fair.
Do it.
No,
Maybe she'll
please
look
don't.
at sympathy points
No.
when we do this.
V prime,
Oh,
taking the different club, the derivative. You're
Whoa.
going to differentiate it. So that's 1000 minus 260x plus 12x squared.
Thank you.
I can factor out a 4.
I'm not sure about the 0.
You don't understand about the 0?
No, I forgot a 0. I just have 26 instead of 200.
Oh, okay.
You said you don't understand 0?
No, I thought she wasn't understanding why we were setting A equal to 0, which would have been a big deal, which is why I was.
You're correct.
You just left out a 0.
Yeah.
I gotcha. Okay, so I need to factor this. Multiply the first and the last together. That's 750x squared.
Can we divide by 4 real quick?
I did.
Oh, why am I so stupid?
That's what she meant by factoring it out.
Yeah, I don't know why I'm so
So I need two numbers that multiply to give me 750.
Mhm.
Add to give me negative 65.
How do you even get 750?
250 times 3, is that not 750?
Yes.
Yeah.
I
75 and 10. No.
Yeah.
Negative.
Yep. But is there, yeah. No.
The 10 would be negative.
No.
No, they gotta both be negative.
Oh.
That doesn't work.
Nope, that doesn't work. Divided by, I did times. 50 and 15.
Yeah.
Sure.
Guys, you can do this. Okay, so I factor out of 50, I get 5 minus x. And factor out a negative 3x, I get positive 5 minus x.
Oh my gosh.
So 50 minus 3x and 5 minus x. Bless you. So setting each one of those equal to 0, you get x equals 50 over 3 and x equals 5.
Would it not be negative?
No, you'd add x to both sides.
Oh.
Let's see. So it's 5 and 50 over 3 here.
2.
Obviously 0. I'm going to use 1 and 6.
I don't think 10 fits.
Okay, so I plug it in here. If I plug in 1, I get a positive.
50 different. That's it.
Where? I mean, after, yeah.
What?
He's talking about 10.
Oh, if I plug in 6, I get a positive and a negative, so it's a negative. Oh, yeah, I can plug in. Well, no, let's see.
It's 16.6
It's 16.
repeating.
So let's do 17.
Oh, I was talking about.
Or 20. Let's do 20. If I do 20, that's a negative and a negative, so it's positive.
I kind of forgotten what we're trying to do here.
Okay, so we are trying to find, the most amount of soup. So which one's a maximum?
The 5.
The 5. Yeah, going from increasing to decreasing.
Say it like The 5.
The 5.